April 2020 semester ICT 6900 Advanced Machine Learning কোর্সের lecture 3 তে সবাইকে আমন্ত্রণ জানাচ্ছি। Today's topic is linear regression with multiple variable and also introduction to Octave. Octave is an open source program and it is almost equivalent to MATLAB. For the purpose of learning this machine learning course, we can use the Octave, and that's why we'll introduce this program today. Before we start regression analysis with multiple variable, let us recollect our previous knowledge on regression analysis with single variable. In the housing problem, we have considered the size of the houses as the feature, and which is called the input feature, this column. And the price of the houses, which is actually targeted price, and we can call this as a predicted variable y. And the hypothesis was defined with hs equal to theta 0 plus theta 1x, where theta 0 is the intercept of the line and theta 1 was the slope of the line. So there are two number of parameters, theta 0 and theta 1, and single variable or single feature. So let us discuss about multiple variable now. And instead of only size, there are other features which are bedrooms, floors, and also age of the house. And the price in lakh taka is, as usual, is the predicted variable or the target variable. So there are four number of features and the notations are x1, x2, x3 and x4. So the first column is the size of the house in square feet is the first feature. The second column is the second feature, which is number of bedrooms, and third column is the number of floors. Fourth column is the age of the house, which is x4. So if we have total number of 47 data set or examples, or in this table 47 number of rows, then we call m equal to 47. The notation m is for number of examples. And there are other notations related to multiple variables, and n is the number of features. So these columns, total number of columns is 4. That's why we call it n equal to 4. So don't be confused with m and n. M is the number of training set or number of examples, and n is the number of features. So features and example, two terms. The next, let us come to the other notation, xi. Xi is the input or feature variable or feature values of ith training example. So let us see the example data for second row or second training example. If you want to find out the features of this particular row, then we will write x2 equal to 14, 16, 3, 2 and 40, which is collected from these rows. The elements has to be written in a column, and since a single column matrix is called vector, then we call x2 is a vector. X to the power 2, although it is to the power superscript, but we don't mean that it is the power of x. It's just an index. Now if you want to find out the particular element, for example the number of floors in the second example. So this is all elements of second example. So number of floor is this one, which is third element of this vector. So we'll write x2 and subscript 3. So subscript is the particular element and superscript is the particular row or particular example. So x32 is equal to 2. Let us discuss about hypothesis. Previously we defined hypothesis as hx equal to theta 0 plus theta 1x. where x was the single variable and theta 0 and theta 1 are the parameters, and theta 0 is the intercept of the line and theta 1 was the slope of that line. Now this definition will not hold, and the definition for hypothesis will be now equal to theta 0 plus theta 1 x1, theta 2 x2, theta 3 x3, and theta 4 x4. x1, x2, x3, x4 are the different variables or features, and theta 1, theta 2, theta 3, and theta 4 are the parameters. So, including the constant parameters, there are 5 number of parameters. So let us take an example. The hx is 100 plus 0.12 x1, 0.02 x2 plus 0.02 x3 minus 2.2 x4. So in this example, x1 is the size of the house, which is actually area, and the constant for x1, which is the parameter for x1, is 0.12, and x2 is number of bedroom, 0.02. So this parameter actually determines the influence of number of bedroom over the price. On the price, what is the influence of bedroom is determined by the parameter. Simply x3 is again the number of floors, and let us assume that the influence factor or parameter is same is 0.02. But for x4, the parameter seems to be negative, which is minus 2.2. It means that as the age increases, the price of the house actually decreases. In the previous slide, we have seen the hypothesis is equal to theta 0 plus theta 1 x1 plus theta 2 x2 up to theta 4 x4, where x's were the features or variables and thetas were the parameters. So for the convenience of notation, let us define a new variable x0, and which is assumed to be a constant value 1. And for every example, we'll put x0 equal to 1. That's why we should write x0I equal to 1. So instead of 4 number of features, if there are n number of features, then the hypothesis function should be written for n. And instead of theta 0, we'll write theta 0 x0. Remember that x0 is always equal to 1, but for convenience of the manipulation or convenience of the writing equation, we'll introduce the x0, although it is always 1. So theta 0 x0, theta 1 x1 up to theta n xn. So the x vector is now containing the n number of elements, n plus 1 actually, because x0 is a new variable. So x0, x1, x2 up to xn. So this is a vector of the order n plus 1. Similarly, theta is another vector which is consisting of theta 0, theta 1 up to theta n. So n plus 1 number of elements. So order is n plus 1. So if I rewrite this equation hypothesis in the matrix form, we can write in this manner. The row matrix, that means matrix containing a single row, theta 0, theta 1, theta 2, theta n, and a column matrix x0, x1, x2 up to xn. If I multiply these two matrices, this is nothing but this equation. Theta 0 multiplied by x0, theta 1 multiplied by x1, theta 2 multiplied by x2, and so on. The summation of these all multiplication will be equal to the right hand side, and that will be equal to x theta of x. So if we notice carefully, this matrix is nothing but transpose of this matrix, and the dimension of this theta t is 1 multiplied by n plus 1 matrix. The number of row is 1, and number of column is n plus 1. And the last matrix, which is X matrix, containing n plus 1 number of x's, x0, x1, x2, x3 up to xn, and this is a column matrix, so it is simply X. So if we multiply these two, the result is theta t multiplied by X. So in the summation form, this multiplication, we should write h of x equal to I from 0 to n theta I xi. And if I write the final equation will be h theta of x equal to theta transpose multiplied by x. In the last slide, we discussed about hypothesis, where h of theta x is equal to theta transpose x, where theta and x both are n plus 1 dimensional vector. And if you expand this multiplication, then it becomes theta 0, x0, theta 1, x1, theta 2, x2, etc. up to theta n xn. And by convention, x0 is equal to 1. That means this term is actually a constant term. And in order to maintain the uniformity in the terms and also to make the calculation or expression easier, we write a new variable x0, which is actually equal to 1. And the parameters are theta 0, theta 1, theta 2 up to theta n, and those are expressed in a vector. And the cost function is defined by this expression. And this is very similar to the previous one for single variable. And in case of n number of variables, we have to write j of theta 0, theta 1 up to theta n, which is equal to 1 over twice m, I starting from 1 to m, h theta x of I minus y of I whole square. So j of theta 0, theta 1 up to theta n, we can write by only j of theta, where theta is a vector. So j of theta equal to 1 over twice m, and summation of I equal to 1 to m h of theta x of I minus y of I whole square. It means the hypothesis, that means the predicted value of certain vector x minus the actual value. So difference between the two is the error. So error is square for all the samples. The sample number 1, sample number 2 up to sample number m. If you sum them together and take average over 1 over 2m, then that will be the total error, which is called the cost function. The objective is to minimize this cost function. So gradient descent actually evaluates this logic. So repeat, theta j is to be replaced by theta j minus alpha multiplied by derivative of j of theta. So again, instead of writing individual theta 0 up to theta n, let us write only the derivative of theta j with respect to j of theta. The expression is this one. So this expression has to be made differentiated with respect to theta j, theta 1, theta 0, theta 1, theta 2, etc. So let us see how the formula is evaluated for different theta. For theta 0, theta 1, theta 2, the expression will be different. So in the next slide, we'll discuss about the elaboration of this formula. We have to remember about the simultaneous update for every j. It is very similar to the single variable. We talked about how to calculate the simultaneous update for single variable problem. So it is exactly same for multivariate problem. Let us now discuss about gradient descents when the variables are multiple, not single. Previously, when n was 1, that means single variable, we developed this equation. Repeat theta 0 and theta 1 update. And those updates are made by the similar formula. If you see the difference is for theta 0, there is a 1 there, and for theta 1, there is a xi there. Xi is a single variable, because it was the case for single variable. It is not vector. I is the certain training example. So this formula we are familiar with. In the last lecture, lecture 2, we derived this formula and we explain the formula. And if you see the first formula, which is the updating equation for theta 0, and in this equation the term over there is actually derivative of j theta with respect to theta 0. When you make a derivative with respect to theta 0, the coefficient becomes 1. Similarly, in case of the other formula, the derivative is defined by this expression, and if you see the derivative is j theta, derivative of j theta with respect to theta 1, and the coefficient of theta 1 is xi. That's why xi remains. And we have to make the simultaneous update for theta 0 and theta 1. Let us now discuss about new algorithm where n is greater than 1. That means when number of variables is more than 1, then we call it multivariate regression analysis. And the formula is very similar to the previous one. The only thing you have to remember that the number of x is not singular. It's a more than one x. We define by xj. You see in the formula, theta j should be replaced by theta j minus alpha, which is learning rate, multiplied by 1 over m, and summation over the error. Error means theta h theta xi minus yi multiplied by xj, and this comes from the derivative of j theta with respect to theta j. So in this case, j varies from 0 to n because there are n plus 1 number of elements starting from x0, and you have to remember simultaneous update of theta 0, theta 1 up to theta n. And if you carefully remember the index values, the I and j, I is the index of m training example, which is here. You see in the summation, I starts from 1 and it ends at m. So index for m training example. So it is, we call it 1 index because the starting value is 1. For j is the index for n plus 1 number of features. Since it starts from 0, j, that's why we call it 0 indexed. Now let us discuss about the formula for theta 0. Previous formula and new formula is not different, although it looks like different. Here x0 I remains, but you remember x0 is always 1. That's why this formula is very similar to the previous formula. In case of x1, previously it was simple x because there was only one variable. In this case, the number of variable is more than 1. That's why first variable is x1 and corresponding parameter is theta 1. That's why theta 1 is equal to theta 1 minus alpha times derivative. Similarly, the theta 2 is exactly similar to the theta 1, and here the multiplying factor is x2i. So error multiplied by x2i, and this formula has to be evaluated for every I and then summed together. For calculating this formula for every I, x2i will remain same, only for different example you have to take x2, x2, x2. So like theta 0, theta 1, theta 2, we have to proceed up to theta n. So the formula is similar. If you calculate theta 3, theta 4, etc., theta 5, etc., all the formula looks like similar to the previous three. So now we can say the generalized formula, which is instead of 0, 1, 2, 3 up to n, we can write j, theta j, where j varies from 0 to n and I varies from 1 to m. So in the summation sign, we have to vary I for certain j, and for next j, we have to again take the summation from I equal to 1 to m, but remember that if j changes, j also changes, like x0, x1, x2, etc. So that's all for gradient descent. When we apply gradient descent for multivariate regression analysis, we have to use this formula instead of the previous formula for single variable. In the previous slide, we discussed about gradient descent for multivariate regression analysis. The ultimate objective is to determine the parameters of the hypothesis at the converge point. So let us assume that our hypothesis contains two parameters. One is theta 1, other is theta 2. And we have assumed that theta 0 is 0. That means we neglected theta 0. And we have two parameters because we have only two features. One is x1, size of the house. Other is x2, number of bedrooms. And if we assume that the size of the house varies between 0 to 2000 and number of bedrooms varies between 1 to 5, and keeping the values as it is, if we run the gradient descent algorithm, then it will converge to a certain point. And we can visualize the convergence in contour diagram. So if we keep the values as it is and we study the convergence mechanism, we have to draw the contour diagram. So in case of x1, x2, two variable, the contour diagram will look like this one. This is steep shape contour diagram, a skinny pattern, and this will happen because the sizes or the value range is different. In one axis, in the theta 1 axis, you can see the values of theta 1 advances a little bit because the x1 is very high and theta 2, the x2 is small. That's why the in order to compensate x2, theta 2 becomes very high. That's why these ellipses in the contour diagram, you can see, is a steep shape, is a vertical steep shape. And if you start the gradient descent algorithm and see the convergence point, we have to plot the points in different iteration. And what is contour plot? Contour plot is nothing but the lines of same j theta cost function over the line of a certain closed path. It means over this line, everywhere the j theta is same. And if we gradually proceed in iterative process, then the cost function has to reduce in order to obtain the minimum cost. So let us say we start over there and we proceed a step and it moves towards one cost function to other cost function. Then it may move in the other direction and then other direction. And if we proceed like this, you can see it will take a long step to reach the minimum and it will move to and fro. So that's why cost function will not reduce in a regular manner. And this happens because of the range of the x1 and x2. On the other hand, if we scale down the features value, for example, x1 is scaled down to size divided by 2000, where 2000 is the maximum value. So if we divide all the size data by 2000, the range of the data will be from 0 to 1 because the maximum value is 2000. Similarly, if I divide the number of bedrooms data by 5, the range will be again 0 to 1. So all the features, not parameters, all the features will have value between 0 to 1. So now the contour diagram will look different. And if we plot the contour diagram, it will be circular shape. And theta 1 and theta 2 will proceed in similar manner, not like previous one that in one scale it will proceed in one amount, in other scale it will proceed in the other amount. It will be almost similar amount of proceed in the two axes. That's why the movement will be very simple. And you can see if you start at certain point, it move in one direction and it almost follow the same line or similar line, and it will converge to a minimum point within very short number of iterations. So the idea is you have to make sure the features should be on a similar scale. It's not necessarily that it has to be between 0 to 1, but the range has to be very similar. If you can do that, then the convergence will be easier. So in order to start the gradient descent algorithm, the first job is to scale down all the feature data to a similar range and then start the iteration. Let us discuss about the same range after the scaling. What is meant by the same range? Normally, we expect that the feature variable or feature values should be within -1 to +1, but not necessarily it has to be exactly between -1 to +1. And we do not need the scaling on x0 because x0 is always 1. So keep it 1, and other features has to be scaled down. For example, if you scale down between 0 to 3, it's okay. It's not that it has to be within 1. Similarly, if the range is in the dissimilar pattern, for example, -2 to plus 0.5, it is also okay. But if one of the feature is very in the high range, very high range, -100 to +100, then it's not acceptable. Similarly, if a particular feature is within a very small range compared to 0 to 1 or 0 to 3, etc., if you start from -0001 and goes up to 0.001, this is also not acceptable. Again, if the range is between -3 to +3, not -1 to +1, it is also acceptable. And if it is less than 1, it can be -1/3 to +1/3 like this. So it is also acceptable. So the meaning of similar range means the x values, all the x values will be within a particular range. Not that it has to be 0 to 1, but the values should be comparable ranges. One of the very popular scaling mechanism is mean normalization. What is meant by mean normalization? So the steps are, first of all, you have to replace all features with xi minus mu I. Xi minus mu I means a particular feature, all the data of the particular features should be subtracted with mu I, where mu I is the mean of all the data. And if you do that, and the final converted data will have approximately 0 mean. Do not apply this for x0. x0 should remain at 1. For example, the formula for x1 can be size minus 1000 divided by 2000, where 1000 is the average value and size varies between 0 to 1000. So maximum value is 2000 or the range is 2000. So size minus average and then the range. And the x1 will be converted into minus 0.5 to plus 0.5. Similarly, if you convert x to all the bedrooms data, you convert into x2. So x2 formula will be bedroom minus 2 divided by 5, where 2 is the average value of all the data. And the data varies between 0 to 5 and average value is 2. In that case, range will be in between minus 0.4 to plus 0.6. So generalized formula is x1 equal to x1 minus mu1 divided by s1, where mu1 is the average value of x1 in training set. All the x1 in the training set take average value and that is mu1. And s1 is the range, maximum value minus minimum value, or in some cases standard deviation. So x2 should be converted by the formula, similar formula, x2 minus mu2 divided by s2. So in this way, if we convert all the feature values, first of all subtract mean value from the feature value and then divide by range of that particular features. So in this way, we can have the features data within similar range. Now we shall discuss how to select the learning rate alpha in order to have convergence through gradient descent. And the gradient descent is defined by this equation. Theta j should be replaced by previous theta j minus learning rate alpha and derivative of j theta with respect to theta j. So the learning rate alpha is critical parameter because if we don't choose this alpha correctly or properly, the divergence may occur and it may not converge at all. If we choose alpha with a very small value, then the convergence time may be longer. That's why to have a knowledge of the effect of alpha on convergence is very important. So how to make sure that gradient descent is working properly? So that has to be a question in debugging stage, and also how to choose the learning rate alpha. So checking correct progress of gradient descent is very important, but how to check whether the gradient descent is progressing correctly? Let us say this is a plot of j theta versus number of iteration and the curve is like this. And notice that the x-axis is not theta, it's a number of iterations. So previously we showed you the diagram for j theta versus theta, but this is j theta versus number of iteration. For example, for after 100 iteration, if j theta becomes at that level, so this is the point for 100 iteration. Similarly, for 200 iteration, the point is over there, and theta may be at this stage is a vector of theta 2, and similarly another vector theta 3, and at that point j theta may be at that level after 300 iteration, and 400 iteration may be the another level. So this is a plot of j theta with respect to number of iteration. So if the curve is like this, then you can say that convergence is approaching because we expect that j theta should decrease after every iteration. So the number of iterations required to converge may vary. For example, a certain problem, the convergence iteration number may be 30, in certain problem it may be 300, even it can be 3000, and in certain problem it can also be 30,000. So it is not certain that after how many iteration the convergence will occur. It depends on different factor, also depends on the nature of the problem. So there is some automatic convergence test. One of the test is to declare convergence if j theta decreases by less than a certain small value, say 10 to the power minus 3 in one iteration. After every iteration, you check the value of j theta and you declare that if the value of j theta becomes less than 10 to the power minus 3 at that iteration, then you stop the iteration and we call it as converse. And this small number is actually called epsilon. There may be the case where the j theta will increase after every iteration. For example, this curve shows the value of j theta increases with the number of iterations. After 100 iterations, the value of j theta, and after 200 iterations, the value of j theta is larger than the previous value. So, if j theta increases gradually, it means it will not converge. And j theta may vary like this. First is decrease, then again increase, again decrease, again increase, and so on. So, in both the cases, the selection of alpha may be wrong. So if j theta does not converge or gradient descent does not converge, or it appears that this gradient descent is not working, use smaller alpha, try smaller alpha, then it may converge. Now let us discuss how the value of alpha, that means learning rate, affect the convergence. You remember we plotted a curve j theta 1 versus theta 1 where it was the problem of a single feature and theta 1 was existing but theta 0 was 0. So single variable problem, and you plotted j theta with respect to theta 1. And if the curve varies like this, the minimum point you are looking for which theta 1 the minimum j theta occurs. So if you start at certain point and then start iterating with large value of alpha, the movement like this, the second point will be there, third point will be again there, and so continuously if you iterate, you will see it will diverge. That means the problem will not converge at the minimum point. But if you start at another point where you chose alpha value to be very small, then it will start converging, but the convergence will be very slow because the steps will be very little due to small value of alpha. So both are problem, and you have to have a small value. At the same time you should have a reasonable value of alpha so that it converges at faster rate. For sufficient small alpha, j theta should decrease on every iteration, that is the requirement. But if alpha is too small, gradient descent can be slow to converge. So let us summarize our discussion on alpha. If alpha is too small, slow convergence. If alpha is too large, j theta may not decrease on every iteration and may not converge. And to choose alpha, try different values like 0.001, zero point zero 0.01, then 0.1, and then 1. Every time you will calculate j theta and see how the convergence occurs. And in this example, I have chosen a multiple of 10 for choosing alpha. So these factors, if you use for different value of alpha and see how convergence occurs, then you can choose. You can also choose in between values like 0.003, 0.03, and zero point 0.3. Instead of multiplying factor of 10, you now choose the multiplying factor of 3. So in this manner, you try for different alpha and find out which alpha gives you the best result, best in terms of speed and best in terms of convergence. Let us discuss about polynomial regression. If you look into the data shown in the figure, a straight line cannot be a good fit for this data set. You may think of polynomial equation like this one: theta 0 plus theta 1x plus theta 2x squared. So this equation may be a better fit rather than a straight line. If you draw a polynomial equation, it will be something like this one. And it is not a good fit because if size increases, price cannot go down. So you may think of higher order polynomial like this one, and the drawing of third order equation is something like this one. So in this way, you can see polynomial regression may be useful for different kind of data. So how we'll fit polynomial equation based on our previous discussion? We discussed about multivariable polynomial equation where the hypothesis is defined by theta 0 plus theta 1 x1 plus theta 2 x2 plus theta 3 x3, and if we fit this hypothesis with our polynomial equation, it is equivalent to theta 0 plus theta 1 into size plus theta 2 into size square plus theta 3 into size cube. So it appears that if I choose features in the manner that x1 equal to size and x2 equal to size square, then x3 equal to size cube. So these three features actually fits the multivariate linear regression hypothesis. So in this manner, we can actually fit polynomial equation by defining different input features. The size is given, the size is the dataset that we have collected, but we can generate other features like size square and size cube in this case to have higher order polynomial. One thing I should discuss about the range of the features. For example, x1 is the size and it can be from 1 to 1000 square feet, and size square will be then from 1 to 10 to the power 6, and size cube data will be from 1 to 10 to the power 9. So you can see the range is very different. So you need feature scaling as we discussed earlier. So with the feature scaling, we can make all the features within the similar range. In the previous slide, we discussed about polynomial regression. If the polynomial is of second order, theta 0 plus theta 1 multiplied by size plus theta 2 size square, the fitting of the curve is like this one. But if I extend the size beyond the extreme point, it will be falling curve. It's not a good fit because as size increases, price cannot go down. So let us try another hypothesis, which is theta 0 plus theta 1 multiplied size plus theta 2 multiplied by square root of size. And a square root function is like this one. It is always increases. That's why if I use theta 2 multiplied by square root of size, the fitting will be like this one. So this is a better fit. That's why this polynomial equation may not be is as a normal polynomial. It can be a different kind of polynomial. Now we'll discuss about normal equation. Normal equation means instead of having iterative process, we'll derive an equation where theta can be directly found out, and the process will describe in these slides. So first of all, let us recollect the gradient descent algorithm. In the gradient descent, the j theta looks like this one, and we have to minimize this j theta. So we start with a point over there, and let's start the gradient descent process. So step by step, we'll proceed towards the minimum point, and at one stage, we reach to the minimum, which is marked over there. So this is called iterative process. And in normal equation, the method is to solve for theta analytically, where thetas are the parameters of your regression problem. So in the regression analysis, all the theta, it may be just 2, theta 0 and theta 1. In case of single variable, it can be n plus 1 in case of multivariate linear regression. So the process of finding theta are two. One is just iterative process, and other is directly by solving theta. There are some advantage and disadvantage of directly solving the theta, so we'll discuss later on. Let us first of all concentrate our discussion on how to derive those equations for theta. Let us discuss about the process of finding the normal equation. Let us say this is our j theta cost function, and we want to find out theta for which j theta is minimum. That means at that point. Let us say j theta is expressed by equation a theta square plus b theta plus c. So in order to find out the minimum point, this point, what we'll do, we'll find out the derivative of theta and equate to 0, because at that point the derivative is 0. What does derivative mean? Derivative means the slope of the line or slope of the tangent at certain point. So at the minimum point, the slope is 0. If we set derivative of j theta equal to 0 and solve the equation, we can find out the theta. In our problem, linear regression multivariate problem, the j theta is expressed by this equation. So the number of variable is n plus 1. So we have to solve the similar equation, derivative equal to 0, for n plus number of variables. So with respect to every j, we have to solve this equation. Partial derivative of j theta with respect to theta 0, with respect to theta 1, etc. up to theta n. So there will be n plus 1 number of equation, and we have to solve for those equations to find out theta 0, theta 1 up to theta n. So in order to find out the equation for theta 0, theta 1, theta 2, we have to have first of all the equation for derivative with respect to different theta, and total number of equation will have n plus 1, and our unknown number is also n plus 1. So we can easily solve or find out the expression for theta 0, theta 1, theta 2, etc. We have described the process of finding normal equation, but will not go through the long derivation. The derivation is time consuming, and that is not our purpose. Our purpose is to use those equations. So we'll describe the equation, and before we describe the equation, let us take an example of housing problem, and let us say we have m number of example where m is 4, and the data for example for multivariate problem is like this: size, bedroom, floors, age, and price. So in addition to the features size, bedroom, etc., we have added another feature x0. The value of x0 is always 1, and this is added for the convenience of formulation and solution for the equations. And the rightmost column, which is price is the target variable or output variable. So if we form a matrix with this data, that means x0, x1, x2, x3, and x4, the matrix will look like this one. This is derived from the data from the different column. For example, if I take the different column in the matrix will be m by n matrix, where m is 4 and n is number of column, which is 5, including x0. So this is how the x has to be defined. Capital X is consisting of all the small x's for all the examples. On the other hand, y data is kept in a vector called y, and this is again coming from the column. So this is actually m-dimensional vector. That means 4-dimensional vector. Once you get capital X and small y, you can get the theta for normal equation. And theta is expressed after derivation is like this. Theta is equal to x transpose multiplied by x itself, then take inverse of the multiplication. If you take the inverse and then again multiply by transpose of x and also multiplied by y, so the solution for this or the calculation for this expression will give you a column vector of theta. Our theta will be 5-dimensional vector because number of theta in this case will be theta 0, theta 1 up to theta 4. Total number of elements is 5, 4 plus 1. In the previous slide, we discussed about the formulation of normal equation. We gave you a expression for normal equation, and we have shown how to use that equation for a specific problem of number of example of 4. So let us now elaborate the same knowledge or same idea for m examples, not 4 examples. So if there are m examples, you will have m number of data set, and each data set there will be features and output variable, output value. The feature can be single, so x can be only x0, x1, and the feature can be n number of features. So if it is n number of features, so this xi means actually a vector having x0 up to xn. Similarly, for each example, like the last example, xm means mth example, but in the mth x, it is mean actually is mth vector. One vector, this is a vector where there are n plus 1 number of elements starting from x0 m, x1 m, x2 m up to xn m. Y is a single variable because output is a single output. So ym, y1 to ym are the single elements. If you expand the feature vector for ith example, then it will look like this one. Xi is a vector, x0 is the first feature, x1 is the second feature, x2 is the third feature, or x0 is the 0th feature, which is actually 1, x1 is the first, x2 is the second, and up to xn. So total number of elements is actually n plus 1. And I can be from 1 to m. This is a ith generalized vector, but it can be x1, x2, x3, etc. Superscript can be 1 to m. And that's why you have to be very careful about the superscript and subscript. If you see the superscript, this one is actually example index because I varies from 1 to m, and j is a subscript. These 0, 1, 2, 3 up to n. They are subject the feature index. Which feature? Zeroth feature, first feature, second feature, etc. So dimension of this vector is n plus 1 dimensional vector, and individual scalar, these are individual scalar, x0 I, x1 I, etc. So if you remember the formation of x in the previous example, the first line you remember the size of the house, then number of bedroom, number of floors, and then age. And at the beginning there is a 1. So 5 elements. And these are in the row. But for a certain example, actually this is a vector. This one is the x0, which is 1. This is the x1, that's my first feature, which is size of the house. This is the second feature, which is your number of bedroom, etc. So the features are in column, but you have to place the feature value in the row. That's why you have to transpose this column vector into a row. So the first row will be the transpose of the x1, first example, the transpose of the second x, second example, third example, etc. So first step is you have to form the x, which is actually m by n plus 1 matrix, because there are m number of rows and n plus 1 number of columns, because feature is n, so total element including 1 is n plus 1. And x is called design matrix. In our expression for theta, x has to be used, and that is called design matrix. Now let us take an example having one feature, just one feature. So in that case, xi will be equal to 1 x1i, not x2, x up to xn, because we have only one feature. The first element is 1 because x0i is always 1. For every example, the first element is 1. And the second element is the first feature, single feature actually, because we are discussing with one feature example. So if xi is 1 x1i, then this is the column vector. So in order to form the x, you have to make this is every row. So transpose this one for x1, x2, this one, this vector you transpose, then second vector like this one transpose where I equal to 2, I equal to 3, I equal to 4. So all example vector, the vector for the feature, you have to transpose to form the x. So this is nothing but 1 x1i, because this is the element and this is another element. So these two elements in the column you make it row. So 1 x1 2 etc. up to 1 x1 m for mth example. And on the other hand, y is equal to y1 up to ym. So each y has to be written in one element, and this is your column vector, and this is column matrix, which is called vector. So if you now calculate this theta by putting this capital X and capital Y, that will be your theta for theta 0 and theta 1, because there are only one feature. So you can easily calculate theta 0 and theta 1 from this equation, where x and y has to be taken from this pattern. This is x pattern for x and this is pattern for y. So put the value of all examples, x1, all examples, all y, target value, and calculate x and calculate y, then calculate x transpose. This matrix has to be transposed, then multiplied by matrix itself, multiply them and then take inverse. After inverting, you multiply with x transpose and again multiply by y. So that will give you theta. So before concluding this slide, let us make a note. You see the small x without subscript, that means this one. Small x without subscript, there is no subscript. This is actually a vector. And small x with subscript, this one, small x with superscript will be there, but if there is a subscript in the notation, then it will be scalar quantity. So individual feature of individual training set. And capital X is matrix, this one. Capital X, this one. Capital X is a matrix M by n plus n matrix. If you evaluate the dimension of each and every one and multiply and calculate the ultimate matrix size of the total theta, you will end up with n plus 1 dimensional column matrix. Let us discuss on the comparison between gradient descent and direct equation. In gradient descent, you have to choose alpha because the alpha is the learning rate and the number of iteration or speed of the convergence depends mostly on the alpha. But in case of direct equation, there is no need to choose alpha. It will automatically give you the solution. In case of gradient descent, you need many iterations because it's an iterative process. Ultimately, you need number of iteration depending on your problem type and the value of alpha. But in case of direct equation, as the name suggests, the direct solution, so you don't need to iterate. But in case of gradient descent, it works well, even n is large. That is the problem of the direct equation because if n is large, then it becomes slow. And this is because of the fact that you have to invert large matrix and matrix inversion takes a longer time if n is large. So that is end of the discussion on direct equation and we will find out the solution for direct equation convenient in case of certain problem, but most of the machine learning problems we have to use gradient descent. Let us discuss one problem of direct equation. There are some cases where the inversion is not possible. The matrix multiplication x transpose x is non-invertible. In some problem, we'll find that this multiplication result cannot be inverted. So there may be some causes, and one of the causes if there are features having linear relationship among them. For example, you have number of features, and among them there are two features called x1 and x2. One is area in feet square, other is area in meter square. Relationship between meter and feet. 1 meter equal to 3.28 feet. So this is redundant. One is redundant, so you have to remove the redundant one. So if you remove the redundant one, then the matrix will be invertible. The other cause is if you have problem, you have chosen a problem where you have selected too many features. For example, m is lower than n. That means number of features is more than the number of examples or even equal to number of examples. In that case also matrix may become non-invertible. So in that problem you delete some features or use regularization and the topics regularization will cover later on. So that's all our discussion about equation, direct equation, and we'll move to the next topics. You must have realized that we need to program the algorithm that we have already studied. Now, question is which program or which software you will use for programming. And the most recommended program is Octet because this is a high level language and moreover it's open source, and most importantly this is convenient for beginners of machine learning course. For the beginners of machine learning course, it is better to use Octave, and then you can switch to other program. The normal tendency is you make prototype in Octave and may implement in Python, C++, R, etc. That means you develop your initial program, initial algorithm in Octave. But finally, when you implement your system into a reality, you may implement in Python, C++, and R. So that's why in our course we'll use Octave, and let us now discuss the installation process. So go to this link and then download the following version of the Octave executable file, and then double click the downloaded file and follow the instructions, and install a local version, not network version, and allow the installer to create a desktop icon. And finally, in your desktop, you use this icon, GNU Octave Local GUI. And we will make a tutorial on this particular software, and this you will not get this in PowerPoint presentation because we will be using directly the Octave program, so you have to follow the video for this initial tutorial. And as we go in our course, we'll be using different features of Octave, but today I like to discuss only the few fundamentals use of Octave. When you start the Octave program, the screen may look like this one. So if you want to clear the screen, the command is clc. If you want to change the prompt of the command, so the command is ps1 first bracket, and within the first bracket is a double apostrophe, and then within the double apostrophe whatever prompt you want to put, say dollar gap, so that will make a new prompt. So if you want to go back to the original command, the process is same. So you just put greater than gap, so that will be the change in prompt. So let us put CLC again. So now if you want to define a matrix, the matrix you have to start with third bracket, 1 gap 2 gap 3, then semicolon, then 4 5 6 semicolon, 7 8 9, and then bracket close. So you will get a 3 by 3 matrix. So this is how a matrix is initialized or matrix is defined. The next, if you want to set a row matrix, say A equal to say 1 comma 3, and this will be a row matrix. If you want to make a column matrix or vector, single column matrix, which is called vector 1 semicolon 2 semicolon 3. So first element, second element, and third element in the column. So it will be a column matrix 1 2 3. In this way, you can define the matrix. If you want to define a matrix, for example, B equal to 1 colon, not semicolon, colon say 0.1, colon say limit 4. So what does it mean? It means the matrix will start from 1 and it will end at 4 with an increment of 0.1. So there are 17 values and the values are like this one 1, 1.1, etc. So there are certain functions for defining matrix, different matrix. For example, ones is a function, built-in function actually. Ones, say 3, comma 2. That means there will be a 3 by 2 matrix where all the elements will be 1. So this is your ones 3 by 2. Similarly, zeros is another built-in function. Zeros, say 1, 3, comma 2 or 2, comma 3, for example, 3, comma 2. So that will be all zero matrix. So this is how you can define different kind of matrix. So let us now move to the topics where we can define another function which is called random function. So rand, say 4, comma 3, 4, comma 3. So that will be a random function, and you see the random values are these values, which is in between 0 and 1. The normal range is 0, 1. There is another function called I. I is a function which is I, and you have to put the dimension of the identity matrix. So I4. I4 means the diagonally it will be 1, diagonal elements will be 1, and all other elements will be 0. Now let us define some matrix. Say A is equal to 1, 2, semicolon 3, 4, semicolon 5, 6. So this is A matrix, and let us define another matrix. And before I define another matrix, let us check the size of this particular matrix that I just defined. Say A, size of A, that will be equal to 3 by 2, and you can store this in a variable size. So A, so that will give the same array, but the variable name is size. So this is another matrix also. So D, the size is a 1 by 2 matrix, so is a row matrix. So if you want to see the only the number of row, so size and A comma 1. If you put 1, then it will give you the number of row, which is 3. Similarly, if I want to see the number of column, so you have to put 2. So it is a number of column. Now let us define another matrix. V is equal to say 1, 2, 3. So that will be a, let us say 4 also, for 1 by 4 matrix. So this is your V matrix. Then if you want to see the length of V, that will give you the length of V. So this is how you can check the length of single column or single row matrix, but don't check the length of multiple dimension, that means row and column. If a matrix has row and column, don't check the length because it doesn't actually mean anything. Let us move to the another topic. Support the CLC. And if you want to check the current directory is shown in the top of the program. You can see the current directory. The directory now is c under clone users under clone dr.s.m Lutful Kabir. So this is my present directory. If you want to check the present directory, so put the command pwd. Pwd is the present working directory. So that is your present working directory. If you want to change the directory, the cd is the command, but you can also change with this window. This window shows the different files and directories in the present directory. So if you want to go to desktop, for example, you just click the desktop. Let us click to another directory under that, and also under that you can have, instead of writing cd within bracket all this long path, it is better to change the directory through this particular window. So if you want to now check the pwd, so you can see the new path, that means the change path. So pwd will give you the new path. So this is long path. You could type cd and within apostrophe the long path, but that is cumbersome. So if you want to check what are the files and directory in that present directory, so the command is ls list. So this is your current directory. So let us say there is a text file like this one, test.txt, in this directory, and if you want to load this file into your present window, present working workspace. So this file is consisting of a set of data. Let us see what the data is. So load within bracket test.txt, the file name. So that has been loaded. If you want to see what is the different parameters or different variables in your list, you just type who is the variable that is loaded in the workspace now. So there is a matrix A, there is an answer, there is a z matrix, there is a test. You have loaded test txt, and there is also a row matrix that we defined earlier, which is b. So if you want to remove all the variables, so you just put clear. Before I put clear, there is another command called whos, Hows. Whos is the same as the who, but it will show you the detail. So detail like size, number of bytes, class, etc. So if you want to clear all the variables from your workspace, clear is the command. So now you put who, you will see there is no variable now. So let us load the test.txt again. So if you want to go back to the previous command that you have issued, so you just put the upper arrow, and with the upper arrow you can see what are the commands you have used. If you want to load the content of the file test.txt into a variable, so you have to put the command like load and within first bracket and the name of the file test.txt. That will load the content of test.txt into a variable called A. So if you now check again who are the variables. So variable visible from the current scope is only A. So A is the now the matrix which contains these elements. So now if you want to proceed further with the octave different manipulation, so let us define another matrix V. We have already discussed this one, say 1 colon 0.1, then colon say 2. So that will be a long list of elements, which are these elements. So 1, 2, 2, there are number of elements with increment of 1.1. So if you want to store this matrix into a file, say for example save, say within, say simply, not within bracket, simply test1.txt, then the variable, this particular matrix. So that will be this one. And if you want to see the ls means the list in the directory, you can find a new file called test1.txt. Test1.txt contains actually all the elements of V. This V matrix will be in the test directory. Test1, not test directory, test1.txt file. So let us define another matrix A with different values like 1, comma, blank 2, then 3, blank 4, and 5, blank 6 with a closing bracket. So that will be A matrix. If you want to see a particular element, so A within first bracket, the location or the coordinate of the element or the particular row and column. So 3 comma 2 for example. So third row, second column, which is your 6. So let us, the answer is 6. If you want to check all the elements in second row, so 2 comma then just colon, that will be your all the elements in second row, you see 3, 4. Say for example you want to see the elements in first and second row or first or third row for example, and all the columns of those rows. So the command will be A within bracket. First of all, if you want to see only one and 3 row, that means first and second row, then you have to put within bracket 1 and 3, third bracket with 1 and 3, and with comma semicolon. Sorry, should only colon. So that will give you the all the elements of first and third. You see the A matrix, and with matrix this is the first row and this is the third row. So 1, 3, third bracket, then comma, and this colon is for all the columns. So if you want to see only the second, all the rows but only the second column, then you have to put in different forms. Say for example A, then start with this colon, and then comma, only one column, say 2. The colon in place of row or column means that all the rows or columns. So now in the row position we have put colon, that's why all the rows. So you see 246, this 246, 246 is the all the elements in the second column. So that's why you can actually change or see particular elements or particular group of elements. So let us, we want to extend our matrix. We want to add a particular row or particular column. So you have to write A equal to, within dot bracket, A comma, and whatever new column you want to put. So new column maybe say 11 colon 12 colon 13. So that is your new elements of new column, and that will be added with A previous A, and you can see the new matrix where new column has been added. If you want to see all the elements in a single column, the command is simply within bracket you have to put a colon. Columns means the all the elements will be in a single column. You see the number of elements in the single column. So let us clear the screen and define A again. Say A is 1 2 colon 3 4 say 5 6 colon then 5 6 third bracket. So this is one matrix. So let us say another matrix B, which is 11 12 13 14 and 15 16 15 and 16. Then this is your B matrix is equal to AB colon AB. So just putting AB, it will be the two matrices will be combined side by side. But if you put a colon in between, semicolon, then it will be in the different row. So first the A matrix, then at the bottom it will be the B matrix. Let us now discuss some function in octet. Say A is a matrix which is defined like this. Say 1 minus 3, say 5, and in the second row it may be minus 2, say 4, say 7. So this is our 2 by 3 matrix, for example. So if I want to take square of each of the elements, then the command will be A dot caret sign. Caret sign stands for your to the power and to the power 2. So each of the elements you can see has been squared. So dot is very important. Without the dot, the operation will not happen. So let us say we want to invert each of the elements. In that case also dot, then slash, and then the matrix. So each of the elements is inverted. So if you want to take logarithm, say log of a, it means each of the elements has been taken log and the output is this matrix. Similarly, exponent e to the power of each of the elements is exp within bracket the name of the matrix. If you want to take absolute of each of the elements, and the output will be, the command is f's matrix and output will be all with positive sign. If you want to take negative of all the elements, then minus a, that will make all the elements negative. If you want to add a certain number with all the elements, say a plus 2, a was this one, and when you add 2 with the a, the matrix is the upper one, that means this one. Say for example, you want to take transpose. Transpose is simply a with apostrophe, single apostrophe. So that will be your transpose. The row becomes column and column becomes row. Similarly, if you want to take a maximum of a, it will give you the maximum in each column. A was like this, and in the each column, first column 1 is maximum, in the second column 4 is maximum, in the third column 7 is maximum. So column wise maximum vector or column wise maximum matrix will be this one. If you issue this command, say a less than 3, say less than 3, it will give you a logical elements. Logical elements means 1 and 0. You see the A matrix over there, and the first element is less than 3, so it is 1. This element is also less than 3, so this is logically 1, true. And this element is not less than 3, so logically is false, so 0. Similarly, the next row. So this output is actually 1 or 0 means it is true to this statement. It is false to the statement if it is 0. Then the command that we studied earlier is this one. So all the elements has been put in a single column. 1, 2, 3, 4, 5, 6. And if you say you issue this command find and a less than 3, then the output is, say for example, 1, 2, 3. That means in this column, the first, second and third, these three elements are less than 3, but this 4th, 5th, 6th element, 4th, 5th and 6th element are not less than 3. So it is the index of this column vector. So this vector, if you form the original matrix in a vector and then you number 1, 2, 3, 4, the element number, and the find command will determine only the position of the elements which follows this condition. Let us discuss how to plot a certain function or figures. So for that, let us define a variable t, which is actually array, starting from 0 with an increment of 0.01 and going up to 1. So this is the elements of the array. Let us also define a function, sinusoidal function, having argument of 2 pi for t, 4 of t, t is the x value. So this y1 is another array having the values from that sine function. So if you want to plot y1 versus t, that means t is your x-axis and y is your y-axis. y1, not y. y1 is your y-axis. So plot t comma y1, that will produce this figure. So this is your sine function starting from 0. You can see the variation. So the value starting from -1 to +1, the sine values, and the t values between 0 to 1. So this is one function. If you want to plot similarly, for example, another function, say y2 is another function. y2 is equal to cosine of, say, 2 pi and 4t. So 4 multiplied by t. So this is your another y function. So that will be your new values from y. So if you want to plot this function, say instead of y1, you have to write y2. So the plot will be this one. You can see the plot. In the plot, the value is starting from 1 because cos 0 is 1. So that is your cosine function. So if you want to plot the two functions on the same figure, so what you have to do, you have to plot the one function first. Say for example, plot t comma y1. Then you have to hold the figure so that you can draw the another curve on it. So hold on is the command. Then you write plot t of y2. And let us say we want to put a color, so which is red. So optional item is to put the color. So the color is, say, comma within apostrophe r, that will make the curve red. So this is your second figure. So you see the figure, you got the two curves. The sinusoidal curve is the blue one, which is starting from 0, and the cosine curve is red one. So let us, we put the level, x level, say for example, level. So the command is x level, and within bracket, within apostrophe, you write time. Time is our x level. So time, and then say y level. Y level is value, values from the function. So within apostrophe, you have to write value, values, for example. So this is your y level. So you want to write legend. Legend means which one is cosine and which one is sine. So legend, the first one is sine. So you write sine within apostrophe, then comma with the second legend, which is cosine, cos, the apostrophe. So finally closing bracket. So that will give you the legend. If you look into the figure shows all this addition, like time, this is your x level, values, this is y level, and the legend over there. So this is your legend. So if you want to clear the figure, so CLF is the command, CLF, clear figure. So in the previous discussion, we have seen how to plot multiple curves on a single figure. So let us discuss how to plot the two or more curves on a single figure. So now let us discuss how to plot the two curves in individual or separate figures. So first of all, you level figure 1 for example, figure 1, and then write plot the first one which is t comma y1. The second one say figure 2, figure 2, you just write figure 2, figure 2 semicolon, and then plot say t comma y. So this is your second plot. So you can see the two figures has appeared. One is sinusoidal function, other is cosine function, and they are in two separate figures. Let us now discuss how to plot two curves in two different regions of a plot of a figure. So let us subdivide our region into two. So the command will be subplot 1 comma 2, and then define which portion you want to plot now. 1 2 means the region will be divided in one row and two columns. So the last one means we are selecting the region 1. So now let us plot the figure. So plot t comma y1. So that will be the first plot. If you see the first plot in the figure, you can see the first plot has appeared. Now let us define the second region by defining 2 over there. 2. 1 2 is the first one row and two column, but in the second region you are now going to plot by which is indicated in the last two. So if you now plot y2 over there, then you will get the two figures simultaneously. Now let us see how to change the axis. So let us say you want to change the x and y axis or any one of the axes. So axis is the command, axis first bracket, and within the first bracket there will be third bracket, and the first parameter is the minimum x. So let us say minimum x is 0.5 and the maximum x is 1, and the minimum y is say for example -2, maximum x is +2. Sorry, maximum y. Minimum y is -2, maximum y is +2. The axis has been changed, and if you see the effect, the second one has changed because your now selected area is region 2, not region 1. If you want to change this axis in different range, you have to issue the axis command when you are in that region. Now we shall discuss how to write program. So you have to go to the editor. At the bottom you can see there are tabs. One tab is called editor. In the editor you have to write your program. Say we want to write a function through which we want to multiply two vector. Vector means one-dimensional matrix, column matrix mainly. So if you want to multiply two column matrix, the element-wise multiplication, and after that we want to add them together. All the multiplication results has to be added them together. So the first word is function. You have to write function and then your output variable. So output variable may be y, and you have to decide a name. Name may be say prediction, or simply multiplication. Say multiply, and then dimension of the vector may be n, and a is one of the vector, b is the other vector. So you have to multiply these two. So at the end, let us write and function. This is n function. So it will be in the same line. So then Let us make a multiplication algorithm. So you have to first of all assume that y is 0, multiplication result is 0, then a for loop for say j equal to 1 colon 3 or n, because n is the dimension, 1 colon, there has to be colon, and 4, and in between we have to write y equal to y, because we are multiplying 1 to 1, so a of j should be multiplied by b of j. So j is our variable index, so we are multiplying two matrices and we are adding with a previous value of y, so all the multiplication result is being added. So we have to save the program. Let us say we are in this directory and we want to store a function with the name multiply. So multiply should be the same name as the function name, multiply, the file name and function name. So save. So from the command window, now we want to use that multiply function. So how to do that? Let us say we have a theta matrix, and which is a vector actually. So vector may be say 0.1 semicolon, because we want to make a column. So semicolon say minus 0.03 comma, or semicolon, not comma, semicolon, and say 0.2. So that is our vector theta. And let us say we define another vector x, where x is another vector, so 1, 1, then again semicolon, then say 2, say 1. So this is our x matrix. So with this two matrix, we want to use that multiply function and see what is the result. So let us say predict is our final output. Predict or prediction, say prediction equal to theta. Use the function multiply. There are three arguments in the function. First argument is the size, so 3. Then first matrix theta and the second matrix x. So that will be our output, and the y output will be stored in the prediction variable. So prediction result is 0.24. If you multiply this to 1 multiplied point is 0.1, 0.03 multiplied 2 is 0.06, and 1 multiplied 0.06 means 0.1 minus 0.04 is the result, and then 0.2 into 1 again 0.2 plus 0.04, 0.24. So this is actually something like our multiple variable regression analysis. You remember in the multivariate regression analysis, there are, in this case, there are two x. One is x0, other is x1, x2. 3x, but x0 is always 1. So this is the x. It means input variables. And these are the theta. For example, we have done the descent algorithm and we end up with this theta 0, theta 1, theta 2. So if you want to multiply these two, the simple multiplication is theta. If two matrix multiplication, theta prime means actually it is you are transposing multiplied with x. If you multiply these two, the result is also 0.24. What does it indicate? Indicates that you are multiplying theta prime is this one, theta prime, and theta prime is now row matrix, single row matrix, and theta prime is being multiplied with x is this one. So when you multiply these two matrices, this matrix and this matrix, This one will be multiplied by this one is multiplied by this, and this one is multiplied by this. That's why the result is 0.24. So this is the simple equation just using two vector multiplication instead of writing that program. This is a loop. With a loop, you are doing the same thing. So this is called vectorization of your problem. You are using vector, directly vector, to get the output. So in many problem of our machine learning algorithm, we have to use the vectorization. So this is an example how to convert a normal equation to a vectorization. So normal equations mean multiply by element, and in this case you are not considering an element. Automatically the multiplication will be between the elements if you do this matrix multiplication. Why we have to transpose? Because we have to make this is row and the previous one column. If you don't make this row, the multiplication will not happen, because multiplication required the number of column in the first matrix should be number of row in the second matrix. If it were vector like the previous definition of the vector, it was just one single column and three row. You cannot multiply this to vector. So this discussion actually gives an idea how to do a program, at the same time how to use vectorization. So with this, we are concluding our tutorial on the octave. At the same time, this is the end of our lecture 3. Thank you very much.